Hello students. We started fiber optics. In that we will today see the types of optical fibers. This is Dr. R. Priya, Professor of Physics, R&D Engineering College. So what we are going to see today is how we are classifying the optical fibers. The main classification is based on three parameters. One is the material, second one is mode of propagation, then third one is refractive index. So based on material, it is classified as glass fiber and plastic fiber. Based on modes, it is classified as single mode and multi-mode fiber. Based on refractive index, it is classified as step index and graded index. Okay. So we will look into this picture now. This will clearly tell about the types, whatever I have told now. So optical fiber based on material, based on mode, based on refractive index. So based on material, it is classified as glass fiber and plastic fibers. Then based on mode, single mode and multi-mode. Based on refractive index, step index and graded index. Now let us go one after the other. Based on material. So we know it is classified as glass fiber and plastic fiber. So it is a self-explanatory. If your fiber is made up of glass, it is called as glass fiber. If the fiber is made up of plastic, it is called plastic fiber. So if it is glass means, then there are few examples given, like what is the exact material of core and what is the exact material of cladding. So here are few examples you can see. If core is made up of SiO2, then the cladding will be a combination of P2O3 with that of SiO2. Then if core is made up of GeO2 along with SiO2, then cladding will be made up of simply SiO2. If core is made up of P2O5 and SiO2, then cladding is made up of SiO2. Then coming to plastic fiber, it is normally made up of tough and durable plastic material. So polymer materials are going to be made use of. So if core is made up of polymethyl methacrylate, then its copolymer will be its cladding. If core is going to be polystyrene and cladding will be methyl methacrylate. So this is the first classification. Now we'll go for the second classification, that is based on the modes of propagation. As I already told you, single mode optical fiber, multi-mode optical fiber. So mode means it is actually the mathematical concept describing the nature of propagation of an electromagnetic wave, like how the information has to be sent through optical fiber. That is the mode. Okay, so if suppose it is single mode, then in general the single mode optical fibers or step index optical fibers, these optical fibers are made up of doped silica. It has very small core diameter that it can allow only one mode of propagation, and hence it is called single mode optical fiber. The cladding diameter is very large compared to its core diameter. Thus the optical loss is very much reduced in case of single mode optical fiber. This structure is now shown. So where it is useful means due to high bandwidth, they are useful for long haul communication systems, which means long distance communication system. Now you can see the structure. So this is the core material. This is cladding. So you can see the structure. The core is going to be of very small diameter, but cladding is comparatively high diameter. Okay, so this is the structure of the single mode optical fiber. So now through this, how the mode of transfer will take place means through the center. So the one ray of information will pass through the single mode optical fiber. That is called single mode optical fiber. Only one ray of information will pass through. Rest of the details are already known to us. So if this is core, then this is cladding, then there will be a primary coating, then there will be a buffer jacket. All these things are already known to us. Okay, so this is the main picture of single mode optical fiber. This is core and this is cladding. If you want, actually we can include the writing also here. Core N1. Cladding N2, where N1 is greater than N2. So this is single mode optical. So next we will see the multi-mode optical fiber. So you can see here more than one ray of information are sent through optical fiber. So in this picture we are showing two rays of information are passing through. See here, this is one. It comes out like this. Similarly on the other side. It comes out like this. Now you can see the next one. Comes out like this. This one. It comes out like this. So this is multi-mode. So more than one ray of information is sent through optical fiber. So in order to accommodate more modes of information to be sent through optical fiber, the diameter of the core is wider here. And cladding and core, you can see the diameters are actually comparable. There is no huge difference like how we have seen in the single mode optical fiber. Okay, and this picture is the isometric view. You can just see easily the what is that, core, cladding, all the mechanical jacket, everything. So all these basic structure is shown here. Okay, so let us read the content. The multi-mode fiber can be manufactured both as step index and graded index fiber, about which we will know in the next classification. Okay, so the core diameter is large compared to single mode optical fiber, that it can allow many modes to propagate through it and hence called as multi-mode fibers. The cladding diameter is also larger than that of the single mode optical fiber. The structure of the multi-mode is shown in the picture. So because of its less bandwidth, it is very useful for short distance communication, which means if I have to tell some industrial applications in some instrument, say for some surgical purpose, where you need only a short distance. So there and all we will be using multi-mode optical fiber. So basically the differences between single mode and multi-mode are listed here. So single mode, it allows only one mode at a time. Multi-mode, it allows more than one mode. Then it is made up of doped SiO2 material, and here the different examples for core and cladding compounds are given here. Then the core diameter is different, that is very small for single mode, very large for multi-mode. Similarly, cladding diameter is also little smaller for single mode compared to that of multi-mode. Then the protective layer will be almost the same for both, that is 250 to 1000 micrometer. Then optical loss is very low for the case of single mode optical fiber. Because the optical loss is very low, this is used in extreme situations like even military and defense, where very secret information has to be passed from one end to the other end. There we use this single mode optical fiber. Then optical loss is a bit high in the case of multi-mode. Then numerical aperture is as low as 0.08 up to 0.1, and here it is little high, that is 0.12 up to 0.5. Okay, so this is the light gathering ability, you should not forget that. So naturally for single mode it will be lesser, and for multi-mode it will be more. Then bandwidth of the spectrum is greater than 50 megahertz per kilometer. Then bandwidth of the spectrum is much lesser than 50 megahertz in a kilometer. Then there is no dispersion when it is single mode optical fiber. That is why very secret informations, very sensitive applications there and all, we will be using only single mode, no dispersion at all. Dispersion will occur because of the degradation of signal. Then launching of light into fibers, connecting to fibers, fabrication of fibers are all difficult for the case of single mode, but all these are little easier for the case of multimode. Cost of fiber is very high. Here the cost of fiber is very low. Application is long distance communication. Here it is short distance communication. Now next classification is based on refractive index. So first one is step index fiber. The second one is graded index fiber. I hope you remember these two we have seen when we discussed about multimode optical fiber. So at that time I said this you do not know, now you will be seeing it as a classification in the next one. So that is this, that is step index optical fiber and graded index optical fiber. So what is this step index optical fiber? Let us draw the picture, you will be able to understand. See here, this is the core and this is cladding. Okay, so this is core having N1 as the refractive index. This is cladding having N2 as the refractive index. Now, this N1 is greater than N2. Very good. So much we know. I am just erasing it just for want of space. Okay, so N1 greater than N2. Now, what I draw now is the refractive index. Refractive index for cladding is low and refractive index for core is high. Similarly, we reach the other side now. Once again cladding, so the refractive index is low. So you just connect this. It is something like a step. So this is N1 and this is N2. So this is core. For the core, you can see the corresponding width of the core, the refractive index is high. Here the refractive index is low. So what does it mean? Means refractive index will be either N1 or N2. So it is something like a step, only two values, either 1 or 0, either up or down, like something like that. So if you are in the core, it will be N1. If you step down to cladding, it will immediately jump down to N2 value. There won't be any value in between. Similarly, this side also. So that is the meaning. So it is called as step index optical fiber. Okay, let us read the content. If the variation of refractive index of the core from optical fiber axis to core cladding interface is in the form of a single step, then it is called step index optical fiber. The step index optical fiber is further classified into single mode and multi-mode. You understand? So when I am telling based on refractive index, next question what should come to mind is whether it is single mode or multi-mode. Refractive index is fine. What about the number of ray of information which is going to pass through the core? Is it going to be single or it is going to be more than one? So whether it is single mode step index optical fiber or multi-mode step index optical fiber? The answer is both. Both the classification are possible. So the ray of information can be single mode or can be multi-mode. Now you see the picture what we have drawn is same drawn here. So this is the axis. So you can see the N1 value for core. Then it just go down to N2 value. So this is called step index optical fiber. So this is single mode. Okay, so only one ray of information goes. Now you can see it is a multi-mode. Okay, it is a multi-mode. Now next one is graded index optical fiber. In short, it is called as GRIN fiber. Graded, GR, index IN, together is GRIN. So GRIN fiber. So it can be a 2-mark question. What is a GRIN fiber? The answer is very simple. It is graded index optical fiber. And you can write 1 or 2 lines about that. Then you will get the full marks. Okay. So now how this GRIN is going to be? Means once again we have to draw the picture. We don't have space here. I will just draw it smaller. You just see here. This is core and this is cladding. Okay, this is core N1, this is cladding N2. So as usual, N1 greater than N2. So we know the core, the cladding is going to be having N2, lower value. Okay, and for the core, the axis is like this. You will understand why we need the axis here. Now, when it comes to core, we are not going to have a single value of refractive index, whereas from the axis, it will fall down gradually to this value, N2 value. Similarly, on the other side also from the axis, it will fall down gradually to this value. So, what is the meaning? The value of N1 is not going to be single, but it is going to be a range of value. How it is going to be? From the axis, it falls down on both sides till it reaches N2. Okay, so this is the GRIN optical fiber. So what we are able to see is N1 is not a single value, it is going to be a gradual increase or gradual decrease. From the axis if you take, it is going to be gradual decrease on either side. Now once again you have to get a question whether it is going to be single mode or multi-mode. The answer is only multi-mode. It is not worth to have a single mode with GRIN fiber. So spending so much is not worth. So it is always only multi-mode. Okay. Let us read the content. In GRIN fiber, the refractive index varies radially. It decreases continuously in a parabolic manner from the maximum value of N1. So from here it decreases down this way and down this way. So from the maximum value of N1 at the center of the core to a constant value N2 at the core cladding interface. Because of this variation in refractive index, light travels at different speeds in different parts of the fiber. Due to the lower refractive index near the outer edge of the rays, near the outer edge travels faster than that at the center. Okay. So you can see the picture here. A typical picture is shown with a different value of refractive index of the core. That gradual increase, no? N1. See, this is the center. So NA, then the next value NB, then the next value NC, and the next value ND. So by the time by the time it reaches the cladding, so it will be something like this. Okay, so at different values it is shown from this value, then this value, then this value, something like that is shown, NA, NB, NC, ND. So Then when the refractive index changes, then the path of the light also changes accordingly. So like this, you are having so many interface. You can see all the perpendicular lines or the interface. That is where you are able to see a change in the refractive index, then the change in the media, which means it becomes an interface. So you can have number of interfaces within the core itself. It is not simply core cladding interface. Within the core itself, since you are having more refractive index, so many interfaces comes and the light travels through all these and comes out. Okay. Now, let us learn the difference between step index and graded index fiber. So if the variation of refractive index of the core from the optical fiber axis to the core cladding interface is in the form of a step, then it is called step index optical fiber. If the variation is going to be gradual decrease from the core axis to the core cladding interface, then it is called graded index. Then it is a single mode and it is a multi-mode. Then meridional ray of propagation, that is ray axis passes through the optical fiber. Here it is skew ray propagation, that is ray does not pass through the optical fiber axis. Okay, so then the light ray, see how to understand this means like this. See here it is like this, no? Okay, then the axis. So it is something like this. So you can see it is not passing through the axis. It goes like this only. Okay, so this is skew propagation. Whereas it is not the case for the step index. Okay, then the light travels in a zigzag path. The light travels in a helical path. That is what is shown, helical path. Allowed bandwidth is less. Here the allowed bandwidth is more. Then distortion is less in single mode fiber and more in case of multi-mode fiber. Distortion is less or no distortion at all in the graded index fiber. Now next comes how many number of modes can travel through step index optical fiber. So it is a formula. Please by heart this formula because problems will come based on this formula. N step is equal to 4.9 into D into NA by lambda whole square is equal to V square by 2. That is, D is what? Core diameter. NA is numerical aperture. Lambda is wavelength of light and V is called V number. Okay. So this V number is equal to 2 pi by lambda into A into N1 into square root of 2 delta, where A is the core radius, N1 is the refractive index of the core, delta is the fractional index change, which is equal to N1 minus N2 divided by N1. Now same case for if it is going to be graded index, then N graded is equal to 4.9, you can see, divided by 2. Rest of it will be same. So I can write this as 4 V square by 2 means this will become V square by 4. So you can write V number from this equation in this way. Okay, this is one important formula based on which you will get problems. Okay, core diameter is small, that is around 50 to 50 micrometer. Here core diameter is more, which is more than 50 micrometer. So advantages, if you take, cost is very less, lifetime of fiber is more. Here intermodal dispersion is less. Then disadvantages, if you see, intermodal dispersion is more. Disadvantages here is cost is more. So with this we are completing the structure, that is classification of optical fiber. Okay, so we will continue further in the next video. Thank you.